Good afternoon. In this Show Me, we are going to discuss red blood cells and blood typing. Remember that the red blood cells are one of the three formed elements that we discussed last time. And they're one of the formed elements that are not a complete cell. So some of the structural things you should know about the erythrocyte is that it's got a small diameter. Remember, it has a biconcave disc shape, and this is important because of its increased surface area. Remember that the major protein found in the red blood cell is called hemoglobin, abbreviated HB. So we're going to talk more about hemoglobin and its importance in a little bit here. Remember that the red blood cell diameter is fairly small, but it's important to note that sometimes the red blood cell can actually squeeze its shape when it has to pass through a blood vessel. So say you have a narrowing blood vessel and you have a red blood cell that's coming through here, it will start to change shape to squeeze through a small capillary. Remember, the capillary is the smallest vessel found in the human body. It's usually found between the artery and the vein. So the artery typically comes in. The capillary bed is usually a mixture of the two types of oxygenated, deoxygenated blood. And this cell flexibility is going to be important, specifically when we talk about, or when you guys learn about, a disease called sickle cell anemia, which most of you have probably heard before. Maybe you didn't know exactly what it was. But it's a disease where the red blood cell is no longer disc-shaped. It takes on the shape of a sickle. And that can be dangerous because if you imagine this particular cell now trying to travel through those small spaces, it could get stuck easily. It does not travel as well. And what do you think about this particular cell's surface area? Do you think it's going to be higher or lower than the normal shaped red blood cell? Hopefully you said lower, which is the correct answer. And this is why people who have sickle cell anemia suffer symptoms such as fatigue and hypoxia. Do you guys know what hypoxia means yet? Hypoxia. So if we break down the word, hypo refers to lowered, oxia refers to oxygen, so it's lowered oxygen delivery. Lowered oxygen delivery typically to cells or tissue. This could result in ischemia, which is closely related to the word hypoxia, but it's more if there's like entire oxygen delivery problems, like to an entire organ such as the brain or the heart. And this could lead ultimately to infarct. You guys know what infarct means? That's tissue death. Okay, that's not good because typically the tissue that dies will never come back. So if it's the brain, if it's cerebral, like cerebral vascular accident such as a stroke, that brain tissue that undergoes cerebral infarct does not revive at any point. Okay, look at me, I'm getting sidetracked. Okay, back to the red blood cell. So hemoglobin, like we said, is a very important protein, and it is the oxygen-carrying portion of the red blood cell. So this is what actually binds oxygen, and it binds oxygen reversibly, meaning it can bind and then subsequently unbind, which is important because if it were a binding that would not release, that would do us no good. If you look in your book and maybe look through the PowerPoints, you see that the normal values are listed. Typically males are going to have more hemoglobin, more red blood cells. You might have seen. Does anyone know why this is? Does anyone know why males typically have more of this than females? If you're thinking it has to do with hormones, you're right. So testosterone is typically the reason why males have more blood, more red blood cells, higher percentage of red blood cells, thus more oxygen carrying capacity than females. If you look at the breakdown of the word hemoglobin, you're going to get heme and you're going to get globin or globin. And these two structures are important. The heme portion is the pigmented portion. So everyone should know that the pigment is red. Okay, so red. And this is because of the specific atom that we find inside of each heme's group. Does anyone know what atom that is? Okay, it is iron. Remember, that's abbreviated Fe on the atomic or on the chemical chart, the periodic table of chemicals. The globular portion down here, remember, globular portion is this is the actual protein portion, and it's made up of 4 amino acid chains that are all kind of squiggled together in a globular shape. You should remember this from chapter 2, which was chemistry. It's a tertiary type of protein. Okay, globular protein. So when we look at this, look at the picture that's in your book, you will see that the heme portion is found within the globular portion. So we look, here's one part, here's 2, and 3, 4. So we see there are 4 globular groups with 4 hemes, which means that each of these heme groups can carry 1 oxygen. If you put that all together, you will see that there are a maximum of 4 oxygen molecules that can be transported per hemoglobin. So 4 O2s per hemoglobin. Notice in the center, this green structure, this is the actual iron atom. So you see 4 of those as well, contained inside of each globular group. Each red blood cell contains approximately 250 million molecules of hemoglobin. So, that's a lot, obviously. If you think about how many red blood cells there are floating around in the bloodstream and multiply that times 250 million, we obviously are carrying an astronomical amount of oxygen throughout our body at any given moment. So you might have seen in the book something called EPO. What is EPO? EPO is a hormone that is very important for the production and maturation of red blood cells. When your kidneys, so this is kind of a weird place, it's produced in the kidneys, sometimes the liver too, but mostly the kidneys, produce EPO, released into the bloodstream, will then act on the target organ for EPO is the red bone marrow. Remember that the red bone marrow is where all blood cells are produced, red blood cells included. So why would we release EPO into our bloodstream? We would have a case where we were hypoxic. So if we undergo hypoxia for some reason, there are several reasons that we could be hypoxic. Okay, we could be hypoxic because we lost blood. Okay, we're hemorrhaging, lost blood. We also could be hypoxic because we have anemia, whether it be sickle cell, whether it be iron deficient or pernicious anemia. Or we could be in a place where O2 is reduced. We could have gone maybe into high altitude, or maybe we have some sort of debilitating disease such as emphysema, which is going to affect our respiratory system, meaning that we will have delivery problems of oxygen. So these are some reasons why we could be hypoxic and why we would produce then the hormone called erythropoietin in our kidneys that would then work to increase the number of circulating red blood cells. Okay, if this were to happen and we were to increase the percentage of red blood cells in our bloodstream, that would lead to a higher viscosity. You guys know what viscosity means. Viscosity refers to the thickness of a fluid as far as does it flow easily, does it flow with more difficulty, such as water maybe has a lower viscosity versus, say, honey, which is thicker and has a higher viscosity. There are athletes who tend to abuse EPO by using artificial means. Artificial EPO supplements that will mimic its effects and will increase their hematocrit. And why would this be beneficial for an athlete? Why would this be beneficial? Because then they have higher oxygen delivery to their muscle tissues, obviously then increasing their performance. You guys have all heard of Lance Armstrong, I presume, famous cyclist who won the Tour de France several times, and he was then stripped of the record book because he was essentially ratted out by his team, telling them, officials, that he was blood doping, which is a real life term, blood doping. When blood cells are destroyed, typically the spleen is where red blood cells will be destroyed. It's often called the red blood cell graveyard. So where they go to be broken back down. So they're usually broken back down into their respective parts so that we can salvage the iron. So iron is typically saved. Okay, we're going to get rid of bilirubin. You guys heard of bilirubin. Bilirubin will be a yellow pigment, and this is what the heme is degraded down into. The iron's saved, the bilirubin is released, and also the globular portion is broken down into the original amino acids, and then they can circulate throughout the body. Maybe they'll pop back up somewhere else, whether they will be maybe part of the skin or maybe part of the muscle, who knows. But they are now free to go back into the blood circulation. The next topic is going to be blood typing. The human blood type groups are, as listed in this chart, A, B, AB, and O. And it all depends on what type of antigen is found on your red blood cell membrane. So if we look at this picture, blow this up a little bit here. Look at this picture, we see that the antigens, which are found over here on the left side, the antigens are important. So for, say, blood type A, you have these antigens found, these kind of triangle-shaped antigens found. It's a marker that's found on the outside of the red blood cell. For the B type of blood, we have this more round shaped, and it's just giving, they're not this actual shape in real life, they're more complex than this, but they're just doing this for simplicity's sake. This round shape that will indicate that particular antigen. If we look at the AB group, we have both. So you have both shapes found, the A and the B antigen. And then when you look at the blood type O, you have no antigens. So look at this membrane here. There are no antigens found on the surface of the plasma membrane. Now, in addition to that, we also have antibodies. Now, if you remember what an antibody is a protein that will bind to something foreign. So it's going to bind to a foreign antigen, Meaning, if we were to take this particular blood cell and place it down here into this type of blood, these antibodies, which notice they have the same shape, they fit together with the opposite. So the anti-A has this kind of triangle shape, just like the shape up here. So if we were to place this blood cell into O blood, this particular blood cell will be attacked by these antigens, and it will form a reaction called agglutination, which you've seen this word. So agglutination reaction, which is a clumping type of reaction. If you look at the O-type blood, remember that it does not have membrane markers, so it does not have the A or the B. It is considered the universal donor. Why? Because it can be added into any of the other three blood types without worry of its cell, its membrane, being attacked by antibodies. And furthermore, the universal recipient, which is blood type AB, can receive any of the three blood types because it does not have any antibodies floating around. It will not be attacked. So you can put any of these three into blood type AB without worry. Now I'm saying all this not taking into account the RH factor. So if you look through your textbook, you can read about what the RH factor means. That's going to be whether you have a plus or a minus sign after your blood type. So the minus sign indicates that you are RH negative. The plus sign indicates that you are RH positive. Note here on the right side of the screen the percentages. So we see that blood type O has the highest frequency found in the United States, whereas blood type A is number 2, B is number 3, and AB is number 4. So you're thinking, oh, universal recipient, that must be nice because you can just take on any type of blood. Well, look, only 1 in every 25 people, roughly, has blood type AB. In your lab activity for the week, you will be simulating taking blood and adding serums to it to determine whether agglutinations happen, and that will determine blood type. So you will be performing this lab in a simulated activity with PhysioX, which, oops, I spelled it wrong, PhysioX, which you can find by going to either physiox.com or you can find it in the study area of Mastering through Blackboard. And I think that I even put a link on the left, on your left toolbar, linking PhysioX to Blackboard. Correct me if I'm wrong. Some other topics that you'll want to make sure you hit on for Chapter 17 are all of the disorders involved, the details about the white blood cells, platelets, the process of hemostasis, which is the blood clotting. Make sure you definitely know what a thrombus versus an embolus. Make sure you know those terms. And also the diagnostic test. Make sure you look up the CBC, and there's other types of blood tests as well. Thanks for watching, guys. This is the conclusion, really, of my presentation for Chapter 17. Check back for Chapter 18 soon, which will be next week, the heart.